All right, welcome everybody, and we are ready to begin. And today's content session is on SQL on Kubernetes, and we have Ben Weissman and Anthony Nocentino for you. So, yet again, just like every year, we have some of the world's best educators, if I may say so, who are putting up some great training classes for you. And we have about 15 of them this year, and these are virtual. I begin this event with the training classes because apart from a lot of breakout sessions that we anyway do each year at the event, DPS, training classes are a real pick. This year, all of you will be happy to know that if you pick up any training class of your choice, you get free access, live attendance, and recordings of all the sessions for the Data Platform Virtual Summit. And there are many of them, as I talked about. I will not take time to go through all of them. The link is there in the chat window. That's dataplatformvirtualsummit.com. And we're trying to cover the entire stack of Azure data, including Power BI and AI as well. So you would see a lot of SQL stuff, a lot of Power BI, a lot of AI stuff, and everything in between, including the Azure data deployments, ADF, etc. But there's one highlight that we have for today's session that I want to pick up is the future of deployment for modern data applications. And I'm taking this opportunity because it is Ben's and Anthony's webinar. I would want to talk about this training class, but not now. We will finish off the webinar because you're here for some learning, and then we'll give a few minutes to Ben and Anthony to talk about their training class as to what they are covering. Remember, these are 8 hours. This is 4 hours each day, 2 consecutive days, live attendance, and the class gets recorded, and you get recordings also, 12-month streaming access, and of course, all the exclusive content that goes along with the class itself. DPS for us, content has been a big focus. We are a team that reaches out to Microsoft and to MVPs, and we try to bring in the best content in this event. And this year is no different. 100 sessions are already announced, maybe slightly more than 100. So we have about 60 sessions from the community. We have about 45 to another 50 from Microsoft. So all you need to do is just jump over to dataplatformvirtualsummit.com, browse the roster, browse the session. And I remind you again, you don't need to buy a ticket or register for the summit. Just go and pick up a training class. Summit comes along free. And I talked about these sessions. We call them as freshly baked sessions. We just try to ensure that the content we bring to you is fresh, try less of repetition, and that's where the focus has been. So you would see a lot of new titles, new sessions, new content, new demos. So yes, friends, please go talk to your managers, get sponsored, come on board today. The link is there in the chat window. We are all over the internet, so there are Twitter handles that you may follow, Telegram, YouTube. We are on LinkedIn as well. Wherever you are, feel free to follow us and join us so that you can get notified about our free upcoming events and initiatives. With this, over to the rock stars, Ben and Anthony. Over to you, friends. Thank you so very much.
Thanks, Amit. Let me get that sharing started. Can you see that, Anthony?
I can see that. Can you hear me?
Awesome. So for those of you following this event, if you want to tweet about that, please use the unique hashtag Benthany. The greatest love story since I even forgot their name. I mean, who knows? Who cares? Having that said, Anthony, who are you?
Yes. I am Anthony Nocentino. My pronouns are he and him. I am on Twitter at Nocentino. So if you aren't following me on Twitter, please do so. It's my main way to interact with the community. And as of 2 weeks ago, I became a principal field solution architect at Pure Storage. Been a data platform MVP for the last couple of years and have co-authored a pair of books on this exact topic with the gentleman standing next to me, well, in the Zoom, Ben Weissman. Ben, do you want to introduce yourself now?
Of course. My name is Ben Weissman. Also very active on Twitter, and this is also my main point of contact with the community. So please follow me there or send me an email if you have questions. just like Anthony, I'm a data platform MVP for the past couple of years. Anthony forgot one important thing. He's also organizing a very amazing conference, which is called 8KB, which gives you like brain melting 500 plus level sessions. Our host today, Amit, actually spoke at, I think, the last edition of that. So he's one of those brain melters.
You were moderating, right?
I was moderating for exactly. I just wasn't sure if there was another edition in between. I'm also running a couple of events. One of those I want to point out real quick is New Stars of Data. So if any of you want to get into speaking at data events but don't know how, check out newstarsofdata.com. Our call for speakers for the next edition is open, and we will provide you mentors and all the help you need to get into speaking. And with that, enough talking about ourselves, and let's get into some content. We will be talking about deploying SQL Server on Kubernetes today, and we will be only touching a few pinpoints actually, because there's only so much time and only so much content that we can squeeze into that 1 hour. So don't expect to leave with like all the tools and everything in depth. It would be impossible. I don't even, after years of working with that, I have no idea about all the details, but that's what I got Anthony for. But there's a couple of considerations that I want to discuss with you, that we want to discuss with you actually. And then I want to show you what we're going to do today. And I will basically just pushing some buttons, and Anthony will tell you about all the cool stuff that's happening behind the scenes when I do that. He has no idea I was actually going to announce that, but that's what happens if you sign up doing a webinar with me. So, Kubernetes, you got basically two general ways if you want to install Kubernetes. You can do that in the cloud, or you can do that on premises, because it's not like there is only one Kubernetes. It's not like there is this one Kubernetes operating system. Kubernetes isn't even an operating system. And if you do that in the cloud, you can do that either as infrastructure as a service, just running virtual machines there, or there's tons of managed services like AKS, EKS, GKE, and others. Or you can do the same thing on-prem with either bare metal, if you really have the workload to support that, or again, with virtual machines. And with then, let me take a big risk here. Anthony, can you, because I just told people how and where they can install Kubernetes. What is this Kubernetes thingy?
What is Kubernetes? Well, Kubernetes is a container orchestrator. It gives you the ability to deploy applications in containers in a controlled way, but more specifically in code. And that's kind of the number one, I think, benefit of Kubernetes, is being able to describe what you want to deploy and have that be deployed into a data center or cloud for you by something. And that thing is a Kubernetes. So it'll start up the containers. It'll attach storage if you need storage. It'll go and allocate IP addresses for access into the services that you are providing inside of your Kubernetes cluster. And so that really is kind of the essence of Kubernetes, being able to deploy applications in code in a data center or cloud. I do want to call out a couple things in the slide, Ben, to dive a little bit deeper on the managed service side of the house. So things like AKS, EKS, and GKE, those are the managed services from the various cloud providers like Azure or Amazon or Google. And Google was actually the founder of Kubernetes, or kind of the nexus of Kubernetes, which then came out of Google when they open sourced that project and became made it part of the community, or available to the community to contribute. And it's one of the most active projects on GitHub. If you want to check that out, the actual code is available on GitHub, but that's not how we're going to be doing it today. We're going to be deploying it as a PaaS offering in AKS, right, Ben? Is that what we're doing today? Correct. Right. And so we'll be able to do.
Yeah. Real quick. You were talking about these containers. Is that like a VM?
You know, it's you can kind of make an analogy to a VM, but really it's more of a unit of deployment for the application. I'm able to take my application itself, like the binaries and libraries and whatever it is that comprises my applications, configuration files, etc., and package that into a unit that's called a container image. That container image is something that I can share with Ben or you or the internet to be able to very quickly deploy my application in literally a single line of code if you're just doing this in Docker. But in Kubernetes, it's a little more sophisticated because we can do things like resource management, high availability, and things like that. But in the end, all a container is your application wrapped up in a package that I'm able to share with you or whomever I want to be able to share that application with.
All right, cool. Maybe let's just show the attendees what we're going to do today specifically, and then we can chat a bit more, because we're going to do everything live today because we're super brave. So there will be some times in between where we'll be actually waiting for some stuff to, because What we actually want to show you today, because I'm here, many of you that you're here today, you've actually heard of Kubernetes and how hard it can be and how much you have to be like the Linux guru, ninja, whatever, to even get it started. And we want to show you how we can deploy a SQL server on a brand new Kubernetes cluster and all that in less than 10 lines of code. Just to show you, it's actually not that complex. Yeah, exactly. Yeah, I counted it. Well, okay, it's exactly 10 lines. It's not less than.
Did you start from 0?
Exactly. I did the VB way. So what we will do today, I've prepared a nice and fancy virtual machine that has almost nothing on it. I'm going to give you full transparency what I cheated with and installed before we actually get going with that. And I'm going to count that to my full 10 lines of code, of course. And in that machine, what we're going to install are 3 tools, basically. kubectl, which is the command line tool to talk to any Kubernetes cluster. So no matter if you're using which of these options that you're going to be using, AKS, GKE, if you're using it on virtual machines, if you're using it on-prem, on bare metal, on VMs, if you're running a Kubernetes cluster, a multiple Kubernetes cluster, kubectl is kind of your first tool that you're going to be using to talk to that cluster. We're going to do that in Azure, and we're going to do stuff through code. So we're going to use the Azure CLI to talk to the Azure Resource Manager to actually deploy that AKS cluster. And since we'll be deploying a SQL server on that cluster, we kind of want to talk to that cluster. So it kind of makes sense to actually deploy also SQL command line tools to talk to that. And what we will then do is we will deploy an AKS cluster, make this AKS cluster connected to our workstation. So we'll basically get credentials on our workstation to talk to that cluster, or tend to be able to authenticate against that. And then we go ahead and deploy a SQL server in that. And with that, let's just dive straight into that. There we go. So again, full disclaimer, I did a few steps in advance. As you can tell, I'm using VS Code just because I want to make it as easy as possible for all of you to actually follow along what I'm doing here. And you're going to get all the code that we're seeing today. So I did install VS Code, and to make my life easier, I installed Chocolate, a package manager for Windows, and I used Chocolate to install VS Code as well as Zoomit. And I also downloaded the AdventureWorks database because we want to restore some data into that SQL server. And I didn't want to make you wait for AdventureWorks to be downloaded, because that's honestly the least exciting part of all we're going to do today. And
I do want to, can I interject for a moment on Chocolate?
One second, let me hit F8 here real quick.
Okay, understood.
Okay, because what I'm doing here is Choco install, and I'm just pointing it to the Kubernetes CLI, SQL command line tools, Azure CLI, the 3 tools I pointed out with the -y switch. -y basically says any question, accept license agreement, will you donate a kidney to whoever set up this repo? The answer will be yes. And it will just go ahead and install these 3 tools for me. This is going to take a few minutes, so that's why I wanted to hit that first. Sorry, Anthony, please.
Totally. And so to kind of dive a little deeper into Chocolate, it's a fantastic tool, because what you're observing here is you'll be able to, in code, install your application. So he's installing Kubernetes CLI or kubectl, SQL Server command line utilities, and Azure CLI, all in code. It's not just these applications, though. If you go to Chocolate's website, you can search and find things like SSMS, lots of different applications that you're probably using every day. And this way, if you go to a new workstation, you can just write code similar to this, just stand up and install all the applications in your new workstation. Fantastic software. Shout out to Chocolate.
Definitely. I mean, especially for the demo machines that I usually tear down after stuff like this, it is completely priceless, because what this basically does is it downloads all the MSIs and then runs MSI exec on those MSIs to install these tools for us. You can provide additional parameters. You could potentially narrow that down or filter that down to a specific version if needed, or you can use it to upgrade those tools. So, and in this case, we're only doing this for 5 tools. I did it for VS Code and Zoomit before, and I'm doing it for these 3 tools now. In a manual way, that would mean going to 5 different websites, finding the right download, making Internet Explorer, because this is a Windows server, actually download the file, which means you have to get like Harry Potter's magic wand or whatever.
Go find that setting in IE, right?
Download them, hit next. It's going to take forever. And that way, super easy, super smooth, and you get consistent results, which is obviously key for that.
Yeah, but what does this have to do with Kubernetes? Not a lot, other than it gave us the ability to quickly install these tools.
Correct.
Or
And
not so quickly, because this is taking a little bit longer than we thought.
well, it is done. The next step I'm doing here is I'm updating my path environment variable just to make sure that we have access to all of these tools. And the reason why we did that is not to make you wait or for you to make you listen to us chatting. My point is we want to show you how you can get from zero to a deployed SQL server on Kubernetes on a brand new machine without anything. Because all that is included. Okay, now I'm cheating a little bit because I'm actually setting a couple of variables here. And these variables will not count to my 10 lines of code. I'm doing that for easier readability of my code, but I could have just put them directly to my code there. So they will not, with those, it's 15 lines of code. What I'm doing now is I'm running a command called azlogin, which I'm going to be using to log into my Azure account. So it's going to be asking for my username, and it's I'm going to use this one. It's going to ask for my password. And of course, because this is super secure.
MFA. If you're not using MFA, use MFA.
This. Which is one of the reasons why I don't care that you can see my subscription ID and everything, because you will need my actual face to make that do something for you. So
I'm just not even going to make a comment about that.
Having that said, the next command I'm using is az account set. If you have multiple Azure subscriptions or multiple Azure accounts, this will just make sure this is using the right subscription. Then we're going to create a resource group. Basically, and I keep saying a container, which is super confusing in the context of Kubernetes. Think of a resource group like a folder. The thing with that folder is it can't go multi-level. It's a group of resources. A resource group is a group of resources. Isn't that a great explanation? And let me also hit this one because it's going to take a little bit as well. If you're not familiar with how Azure works, this is just how you can get your resources organized. So if you have, well, I have this VM here, I have this AKS cluster there, I have this and that resource, put them into resource groups, and those resource groups could then be moved between subscriptions. Those could be deleted all at once. Those could have specific permissions, all that. What I quietly did in between is I ran a command, az AKS create. Az, my Azure command line utility, AKS, so I'm talking to an Azure Kubernetes service, create, it's going to create it. And all I need is the name for this cluster, which is going to be called my first AKS, the name of my resource group, which is MySQL on AKS. And I'm also passing the switch generate SSH keys. To communicate with your AKS cluster, by default, you will use SSH keys for authentication. And all that switch will do is it will check if you have already created or generated SSH keys on that machine. If there's already some that they can use, so if you already have a key to share for that authentication, cool. If not, it will generate them for you. So just leave that switch in there, and that will make sure we will actually be able to talk to our cluster. Those are all the required parameters. There's about a gazillion extra parameters. Like I could say, hey, because an AKS cluster by default, it consists out of 3 VMs coming from the DS2 something family. I would have to check it in the docs which one it is specifically. Maybe your need is not to have 3 VMs, but 20. Maybe your need is not to have that kind of a small VM size, but a bigger one, or just one single VM. Don't go with a single VM. You always want to have redundancy in your cluster. Don't do single VM, please. I keep seeing that, and I'm like, why? But there's so many features. You could have that cluster auto scale. So, for example, if there's there's a lot of load coming to that cluster, it will automatically add extra VMs. It will automatically add extra pods. And we're going to talk about what a pod is in a sec here, I guess, Anthony.
I guess on that concept or conversation around virtual machines, why would I have more VMs? So you said there's 3. You said there's 20. I mean, is it because of a particular reason? I mean, I know the answer to this question, but I'm trying to set it up for you.
There is a particular reason, because I can, but there's a second particular reason. No, I mean, think of that. You're deploying applications to this cluster. That's essentially what you're doing. And depending on what kind of application you're deploying, you may have different requirements with regards to performance. So one of the typical use cases for Kubernetes is deploying microservices. So you may actually run very small VMs, but a lot of them because you're running lots of microservices. But you may also deploy something like a big data cluster where you say, oh, well, you cannot have a single pod. And again, we're going to talk about what a pod is in a sec here. You cannot have a single pod stretch over multiple nodes. So one pod, one node. You can have one pod on one node now, and then you can have that pod on another node later. And it's not going to be the exact same pod before you ding me on that, Anthony, but another instance of that pod. But just like if you're, and that actually works very well with the VM analogy that we had earlier. Just like when you're designing a virtual machine for your application, so like you're deploying a SQL server, you will make considerations. How big does that server need to be? And that will depend on how big are the databases that you're going to attach to that. What's the expected workload? Is it just like a small backend where you're collecting feedback for an event using a Visual Basic application? Or is it something where you're actually doing real-time stock information trading, where you want to get stock rates and all that coming in streaming with potentially millions of records per second? That will kind of depend on how big you want your VM to be. And that will also depend on, in the case of Kubernetes, how do you want to size your cluster?
So we have a question from the audience. Let's bring this up out loud. So can we have a SQL cluster sharing Docker volumes and mounts? See, I read somewhere that it's not possible to create a SQL Server cluster on AKS. Now, I think what we're asking here is, can you have a shared storage environment and multiple SQL servers potentially accessing that shared storage, like a failover cluster instance? And in that case, no. But Ben, I'm assuming we're going to talk a little bit about the high availability like paradigm that we can get out of Kubernetes. Are we covering that today?
But of course, well, not in depth, cool. But we're going to touch it.
Okay.
And yes. So
cool.
That
now,
cluster has created. So go ahead.
Yeah. I'll save that point until later. So sorry about that.
Our cluster has created, and as you can tell, that took like, I don't know, 3, 4, maybe 5 minutes. And in that time, what happened is our Kubernetes cluster was built based out of a virtual network because we didn't provide one. We could have also deployed it into an existing network. We said, we're not going to provide that, so create one. It created IP addresses. It created storage for us. It created those 3 VMs. All that happened behind the scenes, and we would see all that in the Azure subscription if you would go to the portal right now. What's missing now is the link from our workstation to that cluster, and we can do that using AKS get credentials, pointing it to that cluster. I will provide a switch here called override existing. All that will do is, if I already have a cluster with the same name, which could especially happen when working on a demo machine, not this specific one because this one is brand new, but I usually make it a habit to keep that in there. It will just override those settings, which also means make sure that you use more or less unique names for your cluster, so otherwise you will keep overriding your connection settings. So what that did is it got the authentication information of that cluster, stored it into a local file called .kubeconfig in my home directory. And I can now use kubectl get nodes, for example, to talk to that cluster. So kubectl, again, our tool to talk to a Kubernetes cluster. Get is one of the subcommands of kubectl, which would get me some kind of resource. And the first resource every single cluster will always have is a node. And a node is nothing else than a physical or virtual machine that is acting as your compute resource in that cluster. Any comments on that, Anthony?
No, I was actually answering a question in the Q&A.
Okay.
But
okay, cool.
We're good there. Yeah.
Okay, and with that, we have our AKS cluster up and running. And if we hadn't chatted all that time, and if we had prepared the tools a little bit, that means just getting that Kubernetes cluster up and running, that was less than 5 minutes. So I would lean with not that complicated, because I keep hearing from people on like LinkedIn, Twitter, where people mean like, oh, it's so complex and so complicated to set that up. I think we just proved it is not. Granted, we did not go into like very specific details on how to tune that, on how to tweak that, on how to link it to other Azure services, like for example, Key Vault or something like that. But it's still super easy. That means we can get to the SQL part. And to actually deploy a SQL server on Kubernetes, that SQL server, since it will be a brand new SQL server, it will need an SA password. And to provide that SA password to that new container, we will be using an environment variable, and that environment variable will be handled in Kubernetes through a secret. Anything you want to share on secrets in Kubernetes while I run this command kubectl create secret?
Let's see. They're not encrypted, right? So we need to be careful with that. They're encoded in base64 encoding and stored in basically an internal database inside of the cluster. So there are, if you're in a high security environment, that might be of concern to you, but there are ways to encrypt them if needed, but not by default.
And I never really got the point of even base encoding them, because I mean, base64 can be decoded just as easy as it can be encoded. So I'm sure there is some super geeky tech reason to do that, because it certainly does not add to security in any way. I mean, even PowerShell can, in one line of code, decrypt that base64 string.
True. When someone asked a question about what are the advantages of running SQL Server in Kubernetes, and is there shared storage involved? And I think that's a perfect topic to cover when you open up that YAML file there here in a minute. Let's not forget that.
What I just downloaded is a YAML file from one of my web servers, bookmark.ws, and that YAML, or generally YAML or JSON files, that's the easiest way of deploying stuff repeated in a way that can be repeated, looking for the right word here, on Kubernetes clusters. So, and that single YAML file actually has 3 different kinds of resources in there. So if we just look for the, and of course, I did not install grep. Hang on. Let me fix that real quick.
Using the fantastic utility, Chocolate.
I did that on purpose just to show how easy it is to install. And it does not get me an extra line of code because I could have added it to my Choco line up there. So,
I mean, we're already at 30, 50s. I don't know. I thought this was 10 lines of code, but we'll let you slide.
And I'm going to explain to you why it's still only 10 lines of code in the end, but that's my German efficiency magic. So if you're doing grep kind on that file, we see there's going to be a persistent volume claim, a deployment, and a service in that. Let's take a closer look at that YAML file. Anthony, do you want to guide us a little bit of what's going on here?
Oh, yeah, sure. I mean, all right, this ends at the top of the hour, right? Because I could go all day, like talking.
Yes, and so that's the thing. You have like, I give you like 3.5 minutes to talk about this file tops.
I know we got in trouble once last year. With
Let's
me
not
presenting.
talk about that incident. Let's not do that.
Okay, so the question that came in was why, right? I think the number one reason is being able to quickly deploy SQL Server in code. And so what we're describing here is what a SQL Server instance looks like inside of a Kubernetes cluster, right? And in the end, what we're going to have is a running SQL Server instance in Kubernetes described in this exact file. Now, I can share this file with you. I can put this file into source control, and I can also put this into a CI/CD pipeline, meaning I can build automation around this concept of deployments in code. Moreover, if this thing is in source control, I know exactly what this system looks like, and I can use that to deploy over and over and over again. So that's really the number one benefit of being able to deploy in code. The other question that popped up was about storage, like where does this stuff live? And that's really what we're looking at between lines 1 and line 11 there in the code here. And what we're describing is where the storage that's going to be attached to this container that is going to run our SQL server is going to come from. And on line 8, we see that. In this case, it's a managed premium Azure disk, right? And so what will happen here is we'll get 10 gigabytes. Literally, a virtual disk will be allocated inside of Azure, and then attached to the node that this container or pod will be running on, and then become available for our databases to be stored on. And so that's one of the real powers of Kubernetes, is being able to write code, describe exactly as you want. I didn't have to go and learn a new, well, actually we're learning a new language right now, but learn an additional language that is going to, maybe for tooling for Azure or tooling for Google or tooling for AWS. I can just describe what I want to get storage from the cloud like this, regardless of which cloud that I'm in. And so if we go down a little bit further in this code, we see, starting on line 13, how we're going to describe the SQL server that we want to stand up inside of our Kubernetes cluster. And what we're going to use here is a deployment. And what a deployment is going to do is create a replica set, which will then create the pod. And inside the pod is the running container. And so the deployment describes what we want to do and how we're going to deploy our SQL server. And so we'll get into the code of that in a minute. It creates a replica set, and that replica set has the responsibility of keeping that SQL server online. And so if something causes that SQL server to go offline, that replica set has the responsibility of bringing that SQL server online, right? Not the same SQL server potentially, depending on the failure scenario. Now, the question that popped up in from YouTube is, what are reconciliation loops? Exactly that. There's code behind the scenes because we use a deployment. There's a reconciliation loop that runs behind the scenes that looks at the desired state of the cluster. And what we're describing here is the desired state of the cluster. I want exactly one SQL server running at all times in my cluster based on what I have deployed right here. I can have multiple deployments, deploy multiple SQL servers or other apps. But what's happening behind the scenes is Kubernetes is always checking to see if this pod is actually running. And so that's one type of reconciliation loops. There's other types of reconciliation loops for the described state of the cluster. And so that's the topic for another day. We're going to focus on SQL Server. And so inside that spec right there, we see line 17, that's how we're going to describe exactly what we want. I see replicas 1. I want exactly one SQL Server instance. And we're going to jump down to line 31, and we see containers. And so inside, we're going to run that container exactly once in our cluster. What image is it going to run? It's going to run a SQL Server image from the Microsoft Container Registry, mcr.microsoft.com, and then that's the full path and tag to the container image that we want to run. Going down a little bit further, we can see a reference to an environment variable, so env. Of course, we have to accept the EULA, so we have accept EULA equals yes. Jump down a little bit further, we see the reference to the SA password that Ben just created a few minutes ago with kubectl create secret. The SA password, value from the secret key ref, which is going to be the cluster data store, which is going to actually store the secret. It'll extract that value and make that available to the container that starts up to set the SA password when that container starts in the pod on a node somewhere in our cluster. Going down a little bit further, we can see now where we're connecting the storage that we just allocated a few minutes ago to the container that we're starting up. And so we see we're going to have a volume which has the same names. So there we see MSSQL-data. We're going to attach that volume to the pod, right? On line 44, we're going to reference that volume that's on line 48 and attach it at that location, var opt MSSQL. And so literally what's going to happen is Kubernetes will take that attached disk and make it available to the container or the application running in the container at that file location. So any data that's written lands in var opt MSSQL. And so that's how we're able to persist that data independent of the lifecycle of the container, because that data lives on that disk in Azure or wherever you have storage. And so going down a little bit further, now that we have our storage allocated, our pods up and running, our container or pod is attached to the storage, now we need access to the SQL Server itself, and that's where services come in. And the service will allocate an IP address that will then route the traffic to the container or the pod that is supporting that service, in this case, our SQL service. And so there we see the kind of service, it's the type of thing that we're deploying. We see the ports is protocol TCP, port 31433. So that's where we'll send application traffic. Target port is where the load balancer will send the traffic to inside of the cluster, 1433, a very familiar port to DBAs, and the type load balancer. And so this will allocate a public IP address that we're going to connect to here in a few minutes, and then send that traffic to the correct pod running in our cluster.
2 comments on that. First of all, why are we using 31433? because this port will immediately be open to the public internet for the purpose of this demo. And 3143 gives me 3 to 4 minutes until someone starts trying to hack into my SQL Server. 1433 is going to be like 3 to 4 seconds, kind of. We have a very interesting and important question on the Q&A that I want to get into real quick. So Salam is asking, with this config, if the SQL container goes off, will that data be lost when the pod restarts the container? And no, because one of the basic concepts of Kubernetes is storage and compute are completely separated. So you could even go ahead and delete that deployment and the pod and anything that's around it. So you delete the compute part, as long as you leave the PVC, the persistent volume claim. It would also keep the persistent volume that's behind it. It would also keep the disk in Azure. And at any point in time, I could create a new pod or a new deployment, accessing that exact same PVC, and therefore accessing the very same data. And if you're doing that on purpose by deleting the deployment and bringing it back at a later stage, or if that happens because Kubernetes deletes the pod for scheduling reasons, for maintenance reasons, for upgrade reasons, whatever, and creates a new pod on a new node, Kubernetes will take the disk with it. And there's a couple of specifics to Azure disks in that scenario that we're not going to get into today, because that's a rabbit hole. Let's not. Hi, Andrew. But having that said, that is a very important part. You have the persistent storage, and contrary to the persistent storage, you could have non-persistent storage, and that would indeed be lost the second the pod gets deleted for whichever reason. So for a SQL Server, you will always go for persistent storage, and therefore, no matter what happens to your pod, your data will be safe and reusable. Anything you want to add, or shall we be brave and go ahead and deploy that?
No, I think we should deploy.
And all I do to deploy that is kubectl apply and point it to that single file. So that single line of code, that single command will actually create my persistent volume claim, my deployment, and my service. So
and that's huge, right? Being able to describe in code the storage environment, the application deployment, and the networking to access that application, right? And I've built some pretty cool automation around deploying SQL servers, and it's never been this fast and this, let's say, accurate or robust is probably a better way to say that.
And it is so cool to, if you think about what is happening here, first of all, this is creating that persistent volume. So that is creating an actual physical storage, or it is creating a disk in Azure. We have the service. The service has an external IP. So this allocates a public IP address in Azure. So it creates another Azure resource dynamically for us. And also, since we specifically provided that port and didn't add anything else to it, it will add a firewall rule for that port to be open. It will then go ahead and download the container image for SQL Server, because this is a brand new cluster. This cluster has had no idea what SQL Server is so far. Still, by just saying, hey, you can get it from here, Kubernetes will go ahead, download the image, and then spin it up. Let's see how we're doing here. And it is up and running. So once that's spun up, it will actually start up a new SQL Server. Since it's completely new, since there's nothing in that storage, it will create our master database, TempDB, ModelDB, all that stuff. All by running that single line of code. So Salam, to your question, even if the Kubernetes cluster is on premises, storage and your compute will always be separated. It will depend on what kind of storage you're using. So if you're just using local disks in one node and that node goes down, obviously the data will not be accessible. So you will usually use something like iSCSI, like NFS, or any kind of storage. Anthony may have an idea or two about storage.
I do a little bit.
Where do you work again?
That's another show. That's another show.
No matter what your Kubernetes is, no matter where your Kubernetes is, that separation always applies. And if the pod dies, the database on the persistent storage does not have to do DBCC unless something super crazy happens. And honestly, I've never seen that on a SQL on Kubernetes. So I'm going with generally no. I'm pretty sure someone will have run into a situation where something led to databases being corrupt and you need DBCC. But yeah. Follow up to the previous question, will SQL Server availability group be possible on Kubernetes on an on-prem environment? That is a great question, and we're going to get to that in a second. Because up next, as you can see here, I ran that, and let me just run this again. That command kubectl get pvc pod server. So I'm just getting all that information at once. If I want to connect to my SQL Server now, I do know my port because I specified that 31433, but I will also need the IP address. And I'm super lazy, and especially when it comes to automation, lazy is good. So what I will do is I will filter on exactly that IP. So if I run this command here, it will give me just that external IP address. So let's just run this, save it into that variable. And now I can say SQL CMD pointed to that endpoint, use my SA account, use the password I've created earlier, and just do something crazy like select add version. And there we go. I'm running SQL Server 2019
Yay.
RTM CU11. Woohoo!
So the question is, sorry.
We're running CU11 because we said we want to have the latest. We could also have specified another CU, like CU9, and then it would have been another line of code to actually upgrade it to CU11. How cool is that?
Very cool. Let's field a couple questions real quick because two of which apply, I think, to the scenario. So the question is, did SQL Server get installed? Not sure how it was so fast. I don't.
Kubernetes.
Yeah, it's not that SQL Server got installed. SQL Server is packaged in a container, and that container can then start it. And all a container really, really is under the hood is a process. It's starting a SQL Server process in a special isolated way. And so it doesn't really install SQL Server. It just starts a SQL Server process with all of the stuff that it needs inside of a container, inside of the cluster. And so that's really like the jumping point to understanding the difference in how it's deployed on a traditional server versus in Kubernetes. And the concept of like a Windows service or a Linux service doesn't really apply because the cluster has the responsibility of making sure that the SQL Server stays online, or the pod more specifically stays online.
Cool. Now we want to do something with this cluster, and we're going to get to the backup and restore questions and everything in a sec. One of the issues, or well, I wouldn't even call it an issue. What you can see here is my pod has got a very unique name. It's called MS SQL deployment, the name of my deployment, and then it's just a unique string that gets assigned by Kubernetes. Still, if I want to copy something into that pod, into that container, I need the name of that pod, and that name of that pod will change every single time I redeploy, or even just Kubernetes decides to terminate and spin up a new instance of that pod. So again, I would just use kubectl get pod and get exactly that name into a variable. If I look into that pod, using kubectl exec it and just running ls-l on my data directory, looking for any bug files, so any backup files, what you will see is no such file or directory, because of course, this is a brand new SQL Server. Where would it have that? So let me just do this and copy my AdventureWorks 2017.back in there. So, and then let's run this command again. Boom, there we go. So what I just did is I used kubectl to copy a backup file into that storage. And that, if you've already been using SQL on containers, or if you've already been using even SQL on Linux, you may be slightly familiar with these concepts. If you're coming straight from a Windows shop and so far have only used SQL on Windows, just the way how to actually talk to file shares in Kubernetes, it's just different. But as you can tell, it's not that hard. So let me run this super fancy command to restore that database. There we go. And if we do a select name from sys databases, whoops, there we go. AdventureWorks 2017. How cool is that? Let me just run another Shoko install just because we have a couple of extra minutes and someone was actually asking about SSMS. I don't have SSMS yet installed on that machine, but I'm going to have that in a second. Do you want to get to the backup restore question that we've had real quick?
I think you covered it. It's how do you get data in there? Right.
Okay.
But to follow up with that, I think that's really what we're walking through here is focusing on the code elements, right? Because now this is a repeatable process that we can use over and over and over again. So if you needed to get a database online, restore a system, or restore a database into the system, it's all in code. This is stuff that we could repeat over and over again. And it's not just the parts of, can I write some T-SQL to do these things? Yes, but you can build this whole pipeline using this environment to get these things up and deploy them and get data into them automatically, automagically, really.
And then then it's just another SQL server. You can use all the tools that you're used to. You can use Ola Hallengren's framework. You can use DBA tools. You can use just simple SQL agent backups if you feel like it. You can dump those to an NFS share. You can dump those to an Azure block. Whatever works for you in your existing SQL server will work for you in your Kubernetes SQL server. I guess that's the key here, because in the end, this is just a SQL server.
Yeah, for backups, what you'll want to do. Totally. For backups, what you'll want to do is obviously the number one rule in backups is to get a copy of your data off of the primary storage system to another storage system as fast as possible. And the easiest way to do that inside of Kubernetes is you would have another persistent volume claim to another type of storage, whether it be NFS, an Azure Files share, another Azure disk, or even on-prem, whatever type of storage it is. And so the idea is you'll back up to a local path, but that path will be on remote storage, right? Somewhere else, so that you can get your backups off of the primary storage as fast as possible.
Correct. So one question is, will the code and the recording be shared? The code will definitely be shared. I think the recording will be, but Amit can chime in on that. And while we're waiting here on SSMS to install, which is SSMS is huge, unfortunately. What I would do after that, depending on how we're doing on time, but this is the bonus part anyway, I would also just install DBA tools, because super lazy as I am, I could also use DBA tools to just add that connection and register as a server in SSMS, because there's so much awesome stuff DBA tools can do for me. So I don't even have to remember the password I chose, because I'll just take it from that very same variable.
And they're celebrating their millionth download this week of DBA tools.
Yes.
Fantastic stuff.
That was me. I'm sure that was me. It must have been.
Yeah,
me.
Totally. I am totally responsible for a good number of those.
Okay. While this is installing, well, we may or may not get back to that. But I want to make sure you all have the resources on this. So all of these URLs you see here, they start with bookmark.ws/ and then something. So as pointed out by Anthony before, we wrote a book or two about all this. So if you go to bookmark.ws/ Arc Data Book, you will get to our book on Arc-enabled data services. And Arc-enabled data services would be your way to actually deploy a SQL server on Kubernetes as an availability group. You cannot do that with a vanilla SQL server, but only through Arc. And Arc Managed Instance actually goes GA at the end of this month. So you could do that right now. We have a book on SQL on Kubernetes, so exactly this topic, and it will be published very soon. As pointed out by Amit, we're going to have a precon on this topic. So if you go to bookmark.ws/dpg precon, it will lead you directly to our precon. We have a bunch of courses on Kubernetes and AKS and Arc and BDC and stuff on Pluralsight, so you can also check that out. And if you want to get the source code, so all the PowerShell stuff and all we did today, I wrote a little article for the SQL Server Geeks magazine in the latest edition on SQL Server and Kubernetes, and you will have all the code in there. So just download that and you will have the explanations again, as well as the code samples and bits and pieces. And how do we decide on whether to choose Azure PaaS DB versus having SQL Server installation in Kubernetes? You want to take that, Anthony?
That's a tough question, because you could technically do all of the things that we just
That's why
about.
I said you're going to take that, because if it's tough questions.
You can deploy Azure SQL DB in code. For me, when I'm working with customers around that, a lot of it has to do with skill and platform, right? Can the people in the organization support what is going on and the platform that's been decided upon? So if you're totally in the cloud and you want to just use PaaS services, generally that's going to be an organizational directive, right? Not necessarily, I'm speaking in broad strokes here, but not necessarily going to be a technical decision, right? Oftentimes that comes from management or from architecture teams and things like that. But if you're all in on Kubernetes for the entire rest of your stack and you have a fleet full of Kubernetes skilled folks in your organization, then you're probably going to want to look at something like this, because your team has the ability to most effectively support where the data lives, right? And that's what's important, is
Correct.
being able to deploy this in a sustainable way for your, supportable way for your environment.
I mean, you could use the
often not
code
even
that we've
effective.
used for SQL today and deploy it on-prem, on AKS, on GKE, on any Kubernetes using the exact same code. The only part that would be different would be the tooling that you would use to actually set up the specific Kubernetes cluster. So unless you're really willing to go all in with just one cloud vendor and just one, if you say, well, I don't care because all I'm doing is cloud and Azure anyway, then there's probably a good reason to go with the PaaS offering and not self-manage it. But otherwise, yeah, I would lean towards. So let me just add that to my management studio, open my management studio. And again, because I'm so super lazy, I even put that into a start process command so I don't have to go to my start menu. Would you have the rate of adoption of SQL Server running on Kubernetes in a production environment? I don't have any number on that, to be quite frank.
Yep, answering that in the chat. Mostly I'm seeing it in testing scenarios or organizations that are replatforming their applications. I always, the way that I usually answer this is, we can barely get people to upgrade versions of SQL Server, let alone change the platform of SQL Server, going from Windows to containers to Kubernetes. And so what I'm seeing in organizations is the process of starting that, right? They're thinking about their next generation of their application. So if they're adopting microservices and they're adopting containers, that's when they're revisiting where to store their data. But no one's ripping and replacing their platforms with this right now. I mean, that's pretty much what I've seen in my perspective.
By the way, the most important thing, since this is running on Linux, because we're running Linux containers, we're getting that super sweet tux in SSMS. And with that, we are on top of the hour. So let me say thank you for your time. Please make sure to reach out to Anthony or myself if you have any additional questions. Make sure to download the code. Let us know if there's anything we can clarify on that. We would love to see a couple of you in our pre-con, because all the stuff that we just barely touched today in this webinar, we're going to do that in depth in that pre-con. So what we will be doing in that pre-con is we will start at zero. So what is Kubernetes? How does storage, compute, networking, security, how do these bits and pieces come together? We've used a lot of terminology like pods and containers and storage and PVCs and PVs and services. And we've hopefully tried our best to briefly explain what it is. But again, there is no way to go into full depth. That pre-con will allow us to do exactly that. So we're very psyched to be teaching that. Thank you so much for having us. That was fun. We were very much looking forward to that pre-con where we can really geek out on all of this, where we will not just talk about vanilla SQL, but also Arc-enabled data services and big data clusters. So everything that SQL on Kubernetes has to offer, availability groups and what else. So yeah, that will be amazing. So we hope to see a lot of the attendees there, of course. And again, thank you, Amit and team, for having us and organizing this.
Thank you. Thank you very much, Ben. Thank you very much, Anthony, for making it. We know you had a tight schedule, so glad that you were able to make it finally. Thank you.